In this video, we'll find the intercepts of a quadratic function. From our previous video, I've written down the transformation form and standard form of the function we used previously. We're going to find the y-intercept and the x-intercepts of that function. To simplify our math a little bit, we'll use transformation form. First, let's find the y-intercept. To find the y-intercept, we will let x become 0 and then figure out what y is using transformation form. In our transformation form, we have y equals -3 times x minus 2 squared plus 20. We will let that x become 0 and do the arithmetic. Inside of the parentheses, 0 minus 2 is -2. If we square that, we will get positive 4. We will multiply that by -3 and then add 20. -3 times 4 gives -12, plus 20 gives us 8. This means our y-intercept is 0, 8, because our x was 0 and our y that we found was 8. Now to find the x-intercepts, we'll let y equal 0 and then solve for x. Once again, we'll start with our transformation form, but now we'll let y equal 0 and try to get x by itself. We'll box in the x to remind ourselves what we're going for, and let's try to get that parentheses by itself first so that we can get to the x. This means we will first have to subtract 20 from both sides. If we subtract 20 from both sides, we now have -20 equals -3 times x minus 2 squared. Then we'll divide both sides by -3, and this will give us a fraction on the left, 20/3. Don't worry too much about simplifying that just yet. We will set that equal to x minus 2 squared, because if you take -3 divided by itself, it will cancel out and give you the invisible 1. On the next slide, we'll deal with that square. In a previous video about inverse functions, we said that in order to remove a square, we must use the inverse of a square. The inverse of the square is the square root. Therefore, we will take a square root on both sides. When we take the square root of a square on the right, this will cancel both the square root and the square. When those cancel, we are only left with the inside, which is x minus 2. It is no longer squared. On the left, we now have square root 20/3. Also, since we took a square root, we're going to say plus or minus root 20/3. This is because on the left we have only numbers and no x. If you take the square root of a number in an equation like this, you must put plus or minus in front of it. Our final step to get x by itself will be to move that -2 to the left side. To do that, we'll say plus 2 on both sides. Therefore, our x will now equal 2 plus or minus root 20/3. Now we can simplify the square root a little bit. The first thing to do when simplifying a square root is to make sure we rationalize the denominator. If you have square root 20/3 and you want to rationalize the denominator, we will multiply on the top and the bottom by root 3. You'll always multiply by whatever irrational number, that is, any number within a root, is on the bottom. So we'll multiply times square root 3 on the top and bottom. If we multiply root 3 times another root 3 on the bottom, this will get rid of the root and give us an ordinary rational 3. Therefore, whatever our answer is, it is now over 3, but not within a root. However, the top will still be inside of the root. So remember, when you're rationalizing a denominator, you can expect that your denominator will no longer have a root, but your top will. On the top, we have root 20 times root 3, and this will give us square root 60. One more thing we can do is try to simplify that square root 60 by seeing what perfect squares could divide it evenly. The lowest perfect square that could help us here is 4. If we take 60 divided by 4, we'll get 15. Therefore, we can say root 60 is the same as root 4 multiplied by root 15. But root 4 is just 2. Therefore, we can replace that root 60 with 2 root 15. This will still be over 3. Therefore, our x values will be x equals 2 minus 2 root 15 over 3 and 2 plus 2 root 15 over 3. All we've done is change this root 20 over 3 into a simplified form, 2 root 15 over 3. Notice that both x values will use this. We'll summarize all this on the next slide. So in this problem, we used our transformation form to get our intercepts. For our y-intercept, we set x equal to 0, and we found y, and that gave us a y-intercept of 0, 8. For the x-intercepts, we let y equal 0 and got x. Since we had to use a square root to get it, we ended up with some irrational answers. We simplified the roots down to get the following x's: 2 minus 2 root 15 over 3 and 2 plus 2 root 15 over 3. Therefore, our x-intercepts are going to equal this. We'll say 2 minus 2 root 15 over 3, comma 0, because our y was 0, and also the positive version, 2 plus 2 root 15 over 3, comma 0 again. This is how we find our intercepts using our transformation form.